Hello, my name is Robert Currier, and today I'm excited to talk to you about my presentation on prey dropping in American crows, Corvus brachyrhynchos. My focal behavior for the presentation is prey dropping. My observations in this video were taken at Mukilteo Lighthouse Park, just north of Seattle. In the video, we can see that the crow has identified a hard-shell prey item. During handling, makes the determination that it needs to conduct a prey drop to get access to the prey item. Flies into the air, drops the prey, returns to it, makes a quick determination that it does not need to do a prey drop a second time, appears to eat at whatever is on the inside of that piece of, or that prey before flying back to the foraging area where it previously was with a number of other crow. My causation hypothesis is that coastal American crows in Puget Sound exhibit prey-dropping behavior as an adaptive foraging strategy in response to the availability of hard-shelled, energy-rich prey in the intertidal zone. I base this on Tangren 1982, which found crow to be one of 4 avian species observed conducting foraging behavior in the intertidal zones of the Puget Sound. The author explored the reasoning for the higher composition of intertidal foraging crow in the Pacific Northwest, and found that crow had carved out a foraging niche that was successful. My developmental hypothesis is that coastal American crows, the Puget Sound and Washington state, prey drop while foraging because of their cognitive problem-solving ability when confronted with novel problems, and social learning, which contributes and allows for the exploitation optimization of energy intake from otherwise inaccessible food resource. I base this on Byron, Heathcote, Roots, and Kaslik, 2009, which found that crow were able to solve novel tasks without previous training as to how to accomplish the task, and crow have this innate ability to learn the mechanistic and functional characteristics of problems and then demonstrate reasoning and innovation in complex problem-solving situations. My evolution hypothesis is that prey-dropping behavior in coastal American crows of the Puget Sound evolved an energetically efficient foraging strategy favored by natural selection due to its low handling cost and high energy payoff. I base this on Davenport, O'Callaghan, Davenport, and Kelly 2014, which found the energy expenditure during prey dropping was minimal compared to the transit costs to and from foraging areas. The paper also found that adult crow were more successful than juveniles during prey dropping, indicating an importance of optimizing prey dropping through minimalization of handling time, effectively locating prey, and different drop strategies. My function hypothesis is that prey-dropping behavior in coastal American crows of Puget Sound is an energy-efficient strategy which minimizes cost while maximizing foraging success to increase survival and reproductive successes. I base this first off Crystal and Switzer of 1999, which found the crow did not make decisions on prey drop height solely based on the mass of the prey. Instead, crow were found to demonstrate complex decision-making to maximize energy intake by considering shell hardness, substrate softness, risk of kleptoparasitism, and whether or not prey had been previously dropped. The study is supported by Davenport, O'Callaghan, Davenport, and Kelly, 2014, which quantified energetic costs of prey dropping and commuting to foraging areas, which found prey dropping was energetically low compared to the energy spent transmitting. For my relation to COGS books, I chose Module 5 COG books T10, Feeding and Foraging, specifically optimal foraging theory, which would support that given the abundance of energy-rich hard-shell prey items in the intertidal zone of Washington and Puget Sound, the use of prey dropping maximizes fitness while foraging by lowering energy costs and maximizing energy profitability. Finally provided are my references and a photo of a crow preparing to mob an eagle.